Thank you. Today, I'm going to talk about building fast, scalable game server in Node.JS. This is the first JSConf I've ever attended this year. But this one, by far, has the best conference room. Not only this great view, but also it has the best Wi-Fi signal. The Wi-Fi is so good that I have to keep working all day. And as I speak to you guys at the same time. And I'm Charlie Crane. I'm from China. I work in a company called NetEase. It is a Nasdaq-listed company. It is a very big company in China, actually. And I've been working in NetEase for about 8 years. I have developed in web and game products. But mostly I have more web background, actually. And many people ask me, where do you come from? Which city do you come from, actually? And I replied, I come from Hangzhou. Hangzhou? Oh, never heard of it. We all heard of Beijing and Shanghai, and never heard of Hangzhou. But today, I will let you guys all remember this city, Hangzhou. So, anybody know this guy? Substack. I think most Node.js guys should know this guy because he's very cool and he actually maintained about hundreds of projects on GitHub, only him alone. Very cool guy. And a month ago, he had statistics about toxicities for NPM modules. And here it is. Okay? Not surprised. Number 1, San Francisco. Number 2, Auckland. This is where Substack lives. And number 3, London. Number 4, New York. Number 5, Madison. And which is number 6? Hangzhou, China. Okay. Okay, Hangzhou have 2 biggest internet companies in China, Alibaba and NetEase. And it is also a very good travel city. So if you guys are interested in travel in China, don't miss Hangzhou. So, let's jump into the topic. This is today's agenda. I'm going to talk about our game server framework first, the state, and some scalability issue and performance issue. And because I'm most from web background, I will talk a little bit about real-time application development. Okay, so let's get started. Pomelo is a fast, scalable distributed game server framework for Node.js. It was open sourced about a year ago. It is quite popular now, actually, in China, but not only in China. After I spoke in JSConf.Asia 2 months ago, the NPM download count has been doubled. And many guys is from America and Europe here. And what Pomelo can do? Pomelo is a game server framework. It can develop a mobile game, web game, social game, and even MMORPG. And only in one premise. It needs a real-time multi-user interaction. It means that only multiplayer game need this framework. If you are developing a single-player game, you do not need our framework at all. And it is also a real-time application server framework, actually. It can develop a real-time application holding millions online users. We have an actual user case for that. Pomelo is not a single project. If you take a look at our GitHub, it holds about more than 40 projects there. So, what is all this project about? Well, it includes many demos. And also, there are many client libraries, including C, iOS, Android, and JavaScript, even Unity 3D, all these clients. And many tools like admin console and command line tool, and also some many plugins and libraries like AI, pathfinding, and beneath it is the framework. And this is our GitHub address, and this is our main project. It is rising quite quickly, actually. There are already many success cases in China now, and this is one of it. It is a card game called Shamu, and they have many online users. And this is another one. It is called Ancient Sun. Basically, it is a little like Clash of Clans, but they say they have many online users now. And as I said, Pomelo is also suitable for real-time application. And some guy developed this game, this project. It is a real-time chat, mobile chat application. It can chat in voice and in other ways. And it is actually a very good application. There are also many success cases like that. I will not iterate one by one, actually. There are many card games and many real-time applications. And there are also many job hunting advertisers out there. So this is one of it. Look at the skill. Number 1, Node.JS. Number 2, Redis. Number 4, MySQL. Which is number 4? Pomelo. OK. Many of them is out there like that. Yeah. And today, I'm going to focus on scalability, because I have given many brief talk about this framework before. And today, I'm going to focus on scalability. And to make you guys know what the game like, I will show you a little demo about this game. Let's start the game demo. Because I run in the local, I actually have 5 online users. It can actually hold about 1,000 online users. And the art material is crap. You guys can just ignore it, because today I'm talking about game server. The client-side art material, just crap, OK? And this is what the game like. It is an MMORPG game. It can, where is my mouse? OK. OK, the players can walking around, fight each other. Oh, it can attack the other player, and also can attack the monster. And the monster will circle around, attack me. It is driven by artificial intelligence. And also I can run. And this way, this is an NPC. And I can run to another map area, actually. Oh, here I am. I am in another area. And this is what the game like, basically. OK. So you guys get the idea what the game like, and we can go on. Scalability. Web servers usually have unlimited scalability, but game server usually is not as scalable as that. For example, they have a world record. It said that it can hold about 7,000 online users. But if it is an MMORPG game, it cannot hold that online users, actually. 7,000 is the most. OK, why? Why game server is not as scalable as web? So let's start from the easiest. Long connection. A game server needs a long connection for 2 reasons. The first reason is immediate response time. Game needs to respond in very, very short time, like less than 100 milliseconds. So we must use long connection. The other reason is bidirectional message flow. We not only need to make a request to the web server, we also need to push message back to the client. So we need a bidirectional connect. So we need this long connection. So actually, but this problem is very easy to solve, because we are using Node.JS. This is why we are using Node.JS, because it is designed for event-driven I/O, and it is very good at holding connection. It is very good at real-time application and network incentive application. In our case, if you are using socket.io, we can hold about 25,000 in one process. But if you are using MQTT, it can hold about 120,000 connections. So this problem can be solved. We just eat many memories. We can add a machine and make the online users OK. But the second problem is not that easy to solve. It is called stateful. So web application usually is not stateful. It is stateless. It can partition the randomly, and each request can be routed to any server. But game is designed in different way. Game server in this case is partitioned by area. So what does that mean? So as you can see the demo before, when I'm walking around in the map, I am in one process. When I am escaping to another map, I'm actually escaping to another process. So why design in this way? Because most of the player interaction happen in one map. So we can do it in one process, and all this interaction can be done in memory. This is the nature of game. But because of this partition strategy, we have a problem of stateful. Each request comes from the client side, must be routed to this server, not that server and that server. So how to solve this problem? Actually, this cannot be solved in technical level. It can be depending on game design. We cannot make one area too crowded. We need a balance of area. For example, this is a case of too crowded area. Too much players in one map, and this process cannot hold too much online user, and it will crash. And this is a much better design. It's not that crowded, and the process can hold this online users. And it comes to the third problem. It is quite difficult. It's called broadcast. Because in game, when I'm walking around or fighting, I need the other players see me, right? So I need to push message to all the other players. If there is only one player in the area, so I only need to push message to me or no message at all. So one message in, one message out. If there are two players in the area, how many messages? I need to notify myself and notify to another player. So 2 messages in, 4 messages out, that is okay. And if there are about 4 players, how many messages? 16. That is also okay. Node.JS can handle this, no problem. But if there are about 100 online users, how many messages? 10,000. That is a lot of messages. That is quite heavy. If there are about 1,000 players in one area, how many messages? 1 million. Holy shit. No process can hold this online users. So how can we handle this? Okay. The first strategy is quite easy, actually. It is called AOI. It is an algorithm. The idea is that when I broadcast to all the other players, I do not need to broadcast all the players in the map. I only need to broadcast to the players who can see me. So this is what this module is built. We use an algorithm called tower. And in the center is tower. And in the screen, who can see me? Only the center. This 9 rectangles can see me. And all the outside cannot see me. So I need not to notify all the other players. I only need to notify all the 9 rectangles in this area. Okay. This can save a lot of broadcast. And the second problem, the second solution is separate process. I remember the guy before have talked about it, yeah. If we have all the logics in one process, for example, game logic and broadcast logic, all these process can eat a CPU, right? So fight each other, and the CPU will go down. Yeah. So what can we do? We can split the process into front end and back end. The front end server will do all the connection stuff. It will broadcast to the client side, but we do not do the business logic. The business logic is done in the back end server. And it have another benefit. Although the game server is stateful, yeah, the back end is stateful, but the front end, it's actually stateless. It can scale up to many, many processes and have no problem. So, and the third solution is also about game design. Because even we have the algorithm of AOI, if all the players is in this single place, so I also need to broadcast all these players, right? We need to dispense the bound place and make the character not they're not crowded in one place. So usually we can dispense this bound place into many places, and each of place is not that crowded. And the fourth strategy is called push schedule, and it is much more about a real-time application or something like that. For example, I need to broadcast and advertise to 5 million online users. Do I need to broadcast in 50 milliseconds? No. I can broadcast in 1 minute or 2 minutes. That is okay. So in this way, I can define our own strategy, and this is how it's defined in Pomelo. For example, I can broadcast about 10,000 messages, and I have a rest. And check out if the CPU is full. I can rest a while, and when the CPU is free, I can broadcast the next message. And it is depend on your business logic and on your schedule strategy. Okay, come to the fourth problem. Tick, it is also called game loop. We not only have game loop in the client side, we also have game loop on the server side. It is something like that. Every 100 milliseconds, I need to update many things. For example, I am dead, so I should remove you from the entity list, make you disappear, and I move. If I move, I will, in the next tick, I will put you to another place. And for example, they have some revive, and also it will drive the artificial intelligence. Because the monster, as I demoed before, the monster will attack me. It is driven by AI, and this logic is also driven in this tick. If a tick is 100 milliseconds, all these updated logics should be far less than 100 milliseconds. For example, 40 milliseconds is at most. We need some space. So how do we solve it? The entity number should be limited because we need to iterate all the entity and do some update stuff. We should limit the entity number. And the second is pay attention to the algorithm because we have AI algorithm in each tick. If the AI algorithm takes too much time, the server will crash. And the third problem is about GC. Because full GC is horrible, right? Especially in Java, it usually takes about a few seconds, and if you configure not right, maybe a minute. Oh, that is crazy for a game. But I find that V8 is very good at garbage collection. Actually, I have talked a few guys from Google in V8 team and the Dart team, and actually, if you can control the memory under 500 megabytes, it have a very, very good GC performance, actually. Even for GC can only take about 30 milliseconds. That is very good. So V8 is very good at it, but we should pay attention to make the memory be limited. We should try to divide the process as more as possible. We should divide the process into single tasks. So in this way, this is end up with the runtime architecture. This is it. Okay, it's quite complicated. In the front end is a bunch of connect servers. It just holds the connection. It will not do the business logic. And the back end is where the business logic is done. As we can see, we divided as many processes as we can. So we not only area server. In actual case, there are usually about 20 processes, something like that. And each one do its own job, like auth server, chat server, stats server, something like that. And when the business logic is done, it will push message back to the connector, and the connector will push back to the client. So it's a quite complicated distributed architecture, right? So how do we solve this? The solution is framework. So let's jump to the third part, framework. And the essence of Pomelo is a distributed, scalable, real-time application framework. Actually, if you take a look at the core of our framework. It has nothing to do with game. It is just a real-time framework. But it is not similar to Media or Derby or something like that. It is not an MVC framework. The core of Pomelo is to make distributed programming as easy as possible. So let's take a brief look at the design goal. The first goal is about abstract of servers. As we can see, there are many, many processes. We need a simple way to scale up, scale down all these servers as easy as possible. And the second goal is about abstract of request response and broadcast. This is the basic API of game server. Request response is similar to web server. Web server also have it, but we need another direction of message. We need to broadcast the message back to the client. And the third design goal is about RPC framework. Actually, we use a very simple RPC mechanism, because in this case, we can make it very easy. But as I have talked all about these issues in other conferences before, many times, so today I'm not gonna dig deep in this area. I'm gonna talk some framework features about scalability. And here is 3 features. The first is server scalability, the second is network, and the third is plugins. So let's start with server scalability. We designed the server as duck type, so almost no configuration file you can start up, but there is only one configuration file needed, and here it is. It is JSON file. And in the up side, we have one connect server and one chat server. So this is the runtime architecture like this. So how can I scale up? We just change this JSON file. 3 connector, 3 chat server. No code needed, just change this configuration file. Boom, scale up. Very easy. We also support another type of scale up. We can dynamically add a server in runtime. It is a command line to to add a server in runtime. So with this mechanism, I can scale up in runtime like cloud computing. We can write a very good share script. If I found the resource is not enough, I just scale up in this share script. Very easy. So this is the first problem. The second problem is network. When we released our framework a year ago, we only support Socket.io client. Socket.io is very good at browser client, right? It is very good at browser compatibility. But it turned out most of our customers, users, are from mobile background. They said, oh, Socket.io using JSON. That is too wasteful. Very much bandwidth. So we need another protocol, like a binary and as small bandwidth as possible. So we developed another connector, which called hybrid connector. And also for mobile, we developed an MQTT connector by ourselves. And so I'm gonna dig deep about hybrid connector. And this is how the package is encoded and decoded. It actually have 3 levels. The first will encode in protobuf. The second is some message encode. I will not dig detail about this. Today I'm gonna focus on protobuf. So this is what usually protobuf is done. We write some protobuf definition, right? And we compile it. We run some command line, compile it, and deploy. Copy this code to our project. And when the entity is changed, oh, I need to rewrite our protocol and compile it again and copy it. Oh, who needed that? Yeah. Oh, we need a better strategy, and this is our strategy. We just write our protocol definition. We do not need to compile. We do not need to do anything. Just this definition changed, boom. We can encode in this definition, and no compilation and no copy. So how do we do it? And this is the configuration case. So as you see, this is our configuration file. It is a little similar to Express. And if you take a look at it, we use a hybrid connector and we use protobuf. And with this configuration, and what else? What do we do? We just need a protobuf definition. And as you can see, we defined in the right side, it's onMove. It is a protobuf definition of the message. And with that, we have nothing need to be done. Just that we push message with onMove, and boom, all these entities will transferred from JSON to protobuf and pushed back to the client. It's that simple. If there is no definition in the right side, it will transfer in JSON format. And it is also lucky that we open sourced Pomelo protobuf as a single project. Any of you guys can use this project in a single project. It's quite easy. And this is the API. I will not dig deep in this. So with protobuf compression, 400 online users. Originally, it needed about 3,600 kilobytes. And with protobuf, about 25%. Well, that saves a lot of network flow. So this is about network. And the last part is plugin. Plugin is a mechanism to extend our framework. So it uses component and events, and it is quite easy actually. But what is the relationship between plugin and scalability? Actually, it's related a lot, because we find that many services need extra service. For example, online status, we need a Redis. We need Redis to store all this online status, right? But if we write all this code in our main project, it is a problem, because our main project will rely on Redis. And if some guy said, oh, I do not like Redis, I like MongoDB, so we need to import MongoDB in our main code base. But with plugin, I can do things like that. We just app.use this plugin, and boom, this framework have the ability of scale up in Redis. And if I need a MongoDB, I just write another plugin and use it, and I have the ability of use MongoDB as online status. Okay, here is another example, master. We use a master process to manage all the other processes. The other processes may be 50 or maybe 20, many processes. So what if this master process is crashed? Crashed or crashed? So how can we guarantee our master process is not crashed? We can use Zookeeper, and we have, this is the strategy. We have 2 slave processes of master. It will only, in normal cases, only this master process do the job. But when I am crashed, it maintains a heartbeat to Zookeeper. The Zookeeper will know that, oh, the main master is crashed. It will emit an on-watch event, and the 2 slaves will select, oh, I want to be master, and the 2 slaves will compete to each other, and one will be selected as a master. And after the slaves become master, the Zookeeper will notify all this message to all the other processes, and the other process know it. Oh, the master is changed. I need to reconnect. So all the other processes will reconnect to the replaced the master process. And should we do it in our main project? Then we need to rely on Zookeeper in our main project. Who needs that? Most of the guys don't need that, but we can write it in a plugin, and we use it, and we have the ability of high availability in master. It's that easy. Okay, so let's jump to the first part, performance. Actually, the performance varies differently in different applications, even games, because there are so much different games. real-time game and not a real-time game. It's very, very different. And in this case, we will focus on the previous case, MMORPG. MMORPG cannot hold that online users actually. There is a bluff. Yeah, NetEase, he said that he can hold about 20,000 concurrent players on one area. Who believes that? It's impossible, actually. In our case, in one area, it is not the whole game. About 800 online users in one process is at most. 7,000 is at most, actually, in real case. So this is our standard. And we actually test in our OpenStack virtual machine, and the machine is not very, very good. And this is the use case. The first use case, only fight. We only test in one area, in one process, stress on one area step by step. And it will log in every 2 seconds and fight each other or fight to the monster in 2 to 5 seconds. And this is the actually picture of fighting each other. In this case, how much online users? 486. We guarantee in this case, the server is in very stable status. It is not as good as our online data, but it is a fairly good data, and we are not bluffing. We are very honest. It is our online data, and it takes about less than 80% of CPU. So the second use case is not fight each other. We just move around, walk around. And the other use case is around, and this is the map. How much online users? About 800 online users. This is almost as good as our online data. And the third case is half fight and half move. It is the usual case in reality, in real game. And in this case, we can hold about 558 online users. So this is the performance data, and the response time is also very quick. Okay, so we still have time, so I'm going to jump into real-time application. Real-time application is very different from game, actually. And we already have many success stories about real-time application, like our message push platform. It can hold about 10 million online users, and also some chat application. In this case, there is not that frequent messages as game, but it usually have much, much more online users. And in some cases, you do not need to push message that real time. You can push message in 1 minute or some seconds. It is all fine. So usually, real-time application is much scalable than game. And today I'm going to take a look at this message push platform. It is used in our company. It actually can hold about 10 million online users now, because there are many products using our platform, and it is all built on Pomelo. So this is the architecture of real-time application. And this is a typical Pomelo architecture, many processes. And the front end is connector. In this case, we use LVS to connect. And the workflow is very simple. We have a group of receivers. It will receive message from RabbitMQ, and it will push message to APNS or connector. It depends on the logic. And it seems quite easy, but it actually has many problems, because there are many challenges out there, and we do it quite well. So what's challenge? First, of course, it is highly loaded, 10 million online users. The second, we need a broadcast. This is the need of product. We need a broadcast to 5 million users in 1 minute. And this is quite difficult, and we have handled it quite well. And the third problem is reliability. We need to push message in any conditions. Even the client is crashed, something is crashed. We need to do high availability, and if the client is crashed, we need to store the message in our in our Redis, and it will push message when the user is online. It is quite difficult, actually. And the fourth problem is about power and network. We need to save our network bandwidth, and there are many strategies about it. And we support all these clients, including iOS. iOS actually supports APNS and MQTT because APNS is not very real-time in our country, actually. So we need another protocol, MQTT. It will push message directly. And in Android, we use MQTT. And in browser, Socket.io is the best choice. And we even support Windows desktop application now. It also uses MQTT. So how do we do it? Because we have Pomelo framework. Pomelo framework is very good at support all these clients in one project. Very, very easy. So I think that's all. I think there is some time for questions. And
does anyone have any questions for Charlie? Raise your hands and we'll go right through you. Anyone? Okay, well, if there were no questions for Charlie, well, that has been our presentation on Pomelo.